Good day, I'm Rex Estrada Obida of Bsed Math 2, and today we're going to discuss about trigonometric functions. But before that, let me present to you my objectives. At the end of the discussion, the students should be able to present different types of triangle, describe different kinds of triangle, elaborate the different parts of a triangle, and solve trigonometric functions. Types of triangle according to the kind of angle. Right triangle. A triangle with a right angle. Oblique triangle. A triangle without a right angle. And there are two kinds of oblique triangle: acute triangle and obtuse triangle. Acute triangle, a triangle with three acute angles. Obtuse triangle, a triangle with no obtuse angle. Equiangular triangle is a triangle whose three acute angles are congruent. Kinds of triangle according to their angles. We have an acute angle in the right triangle, obtuse triangle, and equiangular triangle. We have isosceles right triangle. Kinds of triangle according to the number of congruent sides. Scalene triangle, a triangle with no sides congruent. Isosceles triangle, a triangle with two sides congruent. Equilateral triangle, a triangle with three congruent sides. Isosceles triangle, a triangle with two congruent sides. Equilateral triangle is also an equiangular triangle. Parts of a triangle. Principal parts. Every triangle has 6 parts, namely the 3 sides and the 3 angles. First, the base of a triangle is the side upon which the triangle is made to stand. B is an isosceles triangle. The two congruent sides are called the legs, and the third side is the base. The vertex angle is the angle included by the legs, while the base angle are the angles included by a leg and the base. And last one, in a right triangle, the perpendicular sides are called the legs, and the third side is the hypotenuse. The hypotenuse is the side opposite the right angle and is the longest side. Secondary parts. First, median is the line segment drawn from a vertex of the triangle to the midpoint of the opposite side. Second, altitude is the line segment drawn from a vertex perpendicular to the opposite side, or it is a line segment from a vertex perpendicular to the extension of the opposite side. Third, perpendicular bisector of a side is a line perpendicular to a side of the triangle at its midpoint. Lastly, bisector of an angle of a triangle is a segment whose endpoints are the vertex and a point on the opposite side, dividing the angle into two equal angles. Right triangles. Definitions of the trigonometric functions of acute angle. So in the sign of angle, we need to remember the opposite side over hypotenuse. In the cosine of an angle, we need to remember the adjacent side over the hypotenuse. In the tangent of an angle, we need to remember the opposite side over adjacent side. In the cosecant of an angle, we need to remember the hypotenuse over opposite side. In the secant of an angle, we need to remember the hypotenuse over adjacent side. In the cotangent of an angle, we need to remember the adjacent side over the opposite side. Or in memory aid, we need to consider the SOHCAHTOA. Solving the right triangles using Pythagorean theorem. I am going to show to you a right triangle. Okay. Straight line. And then a straight line and also a straight line. Here is the angle and here is the theta. Since we put the theta here, and the opposite side of here will be the opposite. And here is the hypotenuse. Hypotenuse, and here is the adjacent. It is the angle A, angle B, and angle C. Example. The theta is here. Here is the hypotenuse. This is the adjacent. And this is the opposite. So, we have a given example of 5 and 7. So this will be the angle A, B, and C. And this will be the small letter A, the B, and the C. So they have the value. A is missing. So to get this, we need to use the Pythagorean theorem to find A, the side opposite acute angle A. So in that, we need to follow this formula. C squared equals B squared plus A squared. Since we already have the value of C by 7, so all we need to do is to substitute 7 squared, and then the value of B is 5 squared plus, since we are looking for the A, so copy A squared. So the square root of 7 is 49. The square root of 5 is 25. Still copy the A squared. And then set aside. Put the A squared to the other side. Remain the 25. And then the 49 to the other side with a sign of minus. So copy the A squared. 25 minus 49 to get the product of negative 24. So in order for us to get the value of A, we need to use the square root. So A is equals to the square root of negative 24 is equal to 4.9. So thus, the value of sine A is equal to 4.9 over 7. The value of secant A is equals to 7 over 5. The value of tan A is equal to 4.9 over 5. The value of cotangent A is equal to 5 over 4.9. And the value of cosecant A is equal to 7 over 4.9. Another example. We need to draw a right triangle. So here is the angle and here is the theta. Angle A, B, and C. A, B, and C. This is the hypotenuse. This is the adjacent. And this is the opposite. Still, we need to find A. Since we have the value of B of 4, C is 6. So the same formula we're going to use in the Pythagorean theorem. We have the c squared equals b squared plus a squared. Since we have the value of c of 6, what we need to do is to substitute 6 squared plus 4 squared plus a squared. The square root of 6 is 36. The square root of 4, 16 plus a squared. So a squared will go to the other side and 36 will go to the other side. So we have a squared, copy the 16. Since it has the positive signs, when it comes to the other side, it will carry a negative sign. So negative minus 36. So we have a squared. 16 minus 36 is equal to negative 20. So to make it positive, we're going to get the square root. So square root of negative 20 is equal to 4.47. So sine A is equal to 4.47 over 6. And then tan A is equal to 4.47 over 4. Secant A is equal to 6 over 4. Cotangent A is equal to 4 over 4.47. Cosecant A is equal to 6 over 4.47. So we have another example. Angle A, B, C. A, B, C. So we have the given of 3 and 6. So to get the A, we need to follow the formula of Pythagorean theorem. We have c squared equals to b squared plus a squared. Since we already have the value of c is 6 squared, copy the value of b, 3 squared plus a squared. Square root of 6 is 36. Square root of 3 is 9 plus a squared. And then a squared 9 minus 36. A squared 9 minus 36 equals negative 27. Square root of negative 27 is equal to 5.2. So we have sine A is equal to 5.2 over 6. Tan A is equals to 5.2 over 3. Secant A is equals to 6 over 3. Cotangent A is equal to 3 over 5.2. Cosecant A is equal to 6 over 5.2. So again, using the Pythagorean theorem, we need to follow the formula of c squared equals b squared plus a squared. Since we already have the value of c, or the hypotenuse, 9, the value of b, or the adjacent, is 5. 9 squared is equal to 81. 5 squared is equal to 25 plus a squared. A squared 25 minus 81 equals negative 56. So a squared, square root of negative 56, we have 7.5. That would be the end of my discussion. Thank you.